Hey everybody! I just want to share a little secret with you. Well, it's actually not a secret. I want to share with you my next big build project, my biggest buildest project ever. It's going to be an 8-foot wingspan version of the Bat. And what is the Bat, you might ask? Well, the Bat began life, let me get this right here, as my first and most successful, most funnest airplane design. It looks something like this. You may have seen it featured in a flight test video at FliteFest South. I was, it was kind of the main thing of the show, or something. Anyway, I was in that, and this Bat in particular, actually, it was this wing that I flew in that combat and won that combat, and yeah. So BAT stands for Backyard Airplane Trainer. And hashtag the Bat RC. And this is the first one that I made. And the wingspan is about 30 inches. The length of a sheet of foam board, like Dollar Tree foam board. And you can see it's a very, very pudgy little thing. A lot of people thought that it was a flying wing for some reason. And I was like, no, it's totally not a flying wing. But that's what they thought it was, so whatever. But it's a decent design. It worked out pretty good. It's pretty durable. I've made it to be very durable. And then I made the GigaBAT because the original one wasn't big enough. So I made it twice as large, and that's actually the wing back there that you see in the background and the fuselage. So this is the fuselage for the Bat. The GigaBAT is what I called this one. And this is actually just twice as large. It seems way larger, but it's actually just twice as large as the Bat. So look at that. Crazy, right? See, the fuselage is twice as tall and twice as wide, and just everything was just twice as large. So it's pretty crazy how when you make something twice as big, it seems way bigger. So that's what I did there, and that has well, it has a 5-foot wingspan. I had to cut off some of the back part of it, the aft part, but the span is 5 feet. And I flew this one in the FliteFest. Last FliteFest East last year, and I had to do some building because I had some battle damage, and it was a great time. This thing is so heavy. Oh, and that's right, actually this thing was the bubble bomber as well. If you want to see a video with a big airplane like this one, actually this one with bubble blowers strapped to it, go see that video. I'll put a link, or I might not, I don't know, go check that out. It was an amazing sort of moderate success. It was, yeah. So anyway, what I want to do this year is I want to go bigger, because where else can you go once you've gone bigger? You have to go bigger. So what I'm going to do, I'm not going to double it, because that would just be a little crazy. Although, no. I think what I'm going to do is, the plan right now is to have an 8-foot wingspan. So that's the length of a 4x8 foot sheet of pink insulation foam board, like the thing with like the Pink Panther on it. So I actually just today I bought the materials to start building the wing and the fuselage, and so that's what I'm thinking of doing. So for this one, it's going to be interesting. I'm going to try and do some different design techniques and kind of make this thing fly a little bit better. And I also might kind of need to. Also structurally, it's going to be interesting because it's a pretty long wingspan, and so to get it to be strong but light, that's going to be a little bit of a challenge. And I think what I'm also going to do is actually extend the fuselage a little bit, so that way we have it's less likely that it will be tail heavy. So I'll basically what I'll be doing is extending the motor and battery section a little bit. So that's what's going on. So yeah, I don't really have anything concrete right now, but I just have kind of some ideas. So let me share with you some sketches and the motor that I might use. Right now I am just in the design phase, and I just want to bring you guys along because I thought, well, one, you might have some good input that something I may have not thought about, and also it's just be fun and good to document this and share it with you guys. So here's a nice little sketch that I did of this. I mean, it's gonna look just like the Bat, basically. It's gonna have a really fat fuselage that is going to allow the prop to stay above the ground. So this will be like a little ground belly takeoffs. I might put little wheels on it, or maybe a tail wheel, because usually it sits back if it's depending on how the weight is distributed, or depending on where I put this this upward angle right there. Depending on where that is, it will cause the tail to sit down. And actually, the what I usually or have done on the bat is, well, like you can see here, I'll just show you. So like you can see, the tail is actually on the okay, hang on. That's not a good. Let me get this one. Haha! I've made several of these. So you can see with this one, the tail is actually on the bottom, like of the empennage section. So it would hit the ground. In fact, that's why on this one I put this little what do you call this? Like a little tail protector on this one. So when it sits on the ground, it is protected. So maybe I'll do that same kind of thing. Or maybe I'll put a little wheel in there. I'm not sure. Some landing gear would be kind of cool. It would also probably help takeoffs. So anyway, this is just what I've got here. I've got this little drawing. There's a little motor. And I was thinking about doing a dual motor. I was thinking about doing actually like a vertical, like having one motor up there and then one motor below it, and then having the props like overlap, because there wouldn't be enough space to have, like, because it's going to be some pretty big motors. I'm not sure exactly which motors. I need to do some testing, but I think I've narrowed it down a little bit. But in any case, they'd have a pretty big prop, at least a 12-inch prop, and I think that this section is going to be, what's this going to be? I think it's going to be about 15 inches, 16 inches, I think, or no. Let's see, because the other one was about 10 or 20. Yeah, so I think this front piece is going to be around 16 inches. So yeah, for the props to overlap, they would have to be like not too big, but they might be big enough. But I don't think I'm going to do that. I might do that. I'm not sure. I did actually already. I made a little Simple Planes mock-up of the twin version of this. Oh, and by the way, the name of this is going to be the GigaBAT, because the last one was the MegaBAT, so I'm just going to kind of go with that digital theme. It's going to be the GigaBAT. So I do have kind of a mock-up of that on Simple Planes, but I'm not really sure. I really want to avoid using two motors, because then I'm going to have to use like two motors, two ESCs, two batteries, and it's just going to get, and two propellers, obviously. It's just going to get kind of complicated. But we'll see. If it weighs too much, and just with what I have, I might need to go to that. And speaking of motors, there's one motor I'm going to be testing out. We'll look at that in just a moment. And so what I'm going to do with this one, I think, is actually have like an airfoil shape of a wing, instead of just a totally, I can't even show you right now because the camera's too close, but instead of just a flat, maybe kind of a stepped airfoil like I have on the smallest bat, I'm going to have like it's going to be really quite large. The actual thickness of the wing is going to be quite large, and that's kind of the wing right there. And then what I'm going to do, I think, is going to have like a spar that goes across the wing, possibly right about there. This is a overview of the wing, a top view. This is a cross section, and then, or probably a little bit farther forward, and have the spar. It's going to be about 6 inches. I think that's about what I calculated it for, like, because I heard that you're supposed to be, what was it? Somewhere around, I want to say that's like 10%. Anyway, I have the calculations. But yeah, so it's going to be like a really fat wing, because I want like a lot of lift, and I want drag. What I want is this thing to be a nice, like really slow, just slow moving big thing that's just kind of floating across the sky. It's going to be awesome. And so I'm thinking, the other thing that this brings up is the propeller and the motor, because I've really been curious about like how like just trying to understand how the propeller diameter relates to I guess how it relates to the thrust, but then like other factors aside from just thrust, because if we had like a little EDF fan, like, that gave us a lot of thrust, but it probably wouldn't have enough, what would you call that, torque, I guess, or something to actually get this thing moving, you know, to overcome the friction on the ground and the weight. So I guess the technical term is oomph. Anyway, so that's basically what this is going to look like. We're going to have servos here. I'm thinking about, I might be able to do single servos, but I'm not sure. The controls don't need to be, you know, insane. I don't plan on doing like aerobatics with this or anything. But we'll see about that, because if I do 2 servos for each control surface, well, one, I'm going to be doubling all the servos that I have to buy, and then the other thing is that then I'll have to like match up all the servos, and I don't know. We'll see about that. I'm going to try and come up with some sort of maybe mechanical means of optimizing my servos instead of just adding more servos, because, you know, again that gets complicated, and then, you know, then I got to think about like, oh well, do I have enough, you know, amps? Will the amp draw be too much, like for the receiver? And I'll probably get a BEC, a battery eliminator circuit. Anyway, let me show you some fun stuff before I show you more like paper stuff. This is a motor. It's a big old motor. Can you guess what it is? This, friends, is a Racer Star. Ooh, Racer Star. Is it supposed to look like the Rockstar logo? Because like it does. It looks just like, you know, like the energy drink. It looks like the Rockstar logo. I don't know. I used to drink Rockstars, and sometimes I still do. But don't tell anyone. Anyway, what we have here, just special occasions. What we have here is a BR4114 400 kV motor. This thing is made to spin, well, I think I'm going to be using an 18x6 propeller on here. And actually what I'm thinking about doing is going to smaller propellers, but then using like 2 of them, like stacking them, and then I'm going to have 4 blades, you know what I'm saying? Because what's better than 2 blades? 4 blades. But we'll see. I don't know, because I'll have to figure out, like, you know, I don't want to overload the motor. But look at that thing, man. Look at that big old honking motor. That thing is quite large. It's got some heft to it, but really it's not too big. Now the thing is, I don't really want to buy a big old huge battery that I'm probably not going to use for other stuff. So the biggest I would probably want to go for this would be like 5 cell. Also, it gets pretty expensive, like when you get into higher voltages and all that sort of stuff. So probably the biggest I would go is 5 cell, but I'd really like to see if I could do this on a 4 cell. Just for comparison purposes, here's a quadcopter, and this is what is this? This is a 2205 Lumineer motor right here. And just so you can kind of see the difference there. So it's pretty big difference there. So anyway, yeah, I'm interested in testing this out and then actually testing it out on the airplane once we get it to that phase, because I'm really curious about if we're gonna, you know, that big propeller and the volume of air and how that's gonna really help us, you know, or how that's going to perform, I guess, and whether or not we want something that has like a lot of thrust. Now, the other motor that I was looking at, which actually Banggood is sending to me to do a review on, so I will be doing that, I think, and that is an Emax. Hang on, I have all the specs here. That is an Emax GT 3520. These are just some of my notes here that I write down while I'm supposed to be at work. I'm just kidding. I am totally at work, in case anybody's watching this who happens to be at my work. Anyway, so this is a 950 kV. It's a $35, which is like stupid cheap. It weighs 220 grams. It takes a 3 to 5 cell battery. The prop I'd probably use is a 12.6, so a much smaller propeller, but it draws 65 amps. So I'd need to get like, you know, an 80 amp or larger ESC, but it produces 3,100 grams of thrust, which is pretty nuts. Yeah, 3,100 grams or 6.83 pounds. So I kind of forget that like what I would really like to be able to do is actually like do vertical climbs, but then I think like, well, okay, it's going to be kind of a big airplane. It's probably going to weigh maybe close to 10 pounds or something. So, you know, I gotta be reasonable here. And then here's the Racer Star, and those are some of the specs that I wrote down. And then I probably had to go do something.
But I'm going to use an 18 by 5 propeller, or I think a 5.5 is actually what I have coming on the way, and that's what I'm going to be testing this out with. So expect some motor testing, thrust test, amp draw test to the best of my ability. I don't really have an amp draw setup. But, or no, I do. I don't have a thrust stand, so I'll need to figure out some way of doing like a DIY thrust stand or something. Just like a hillbilly thrust stand. Oh, and then I did some calculations here just in case you're a nerd like me and you're interested. This was for these, I was just comparing these propellers. So this would be on the Racer Star. This would be on the Emax. And comparing, what did I do? I just took the numbers and I just, the numbers of like, so cubic inches per revolution. I just calculated that out. I think this is right. Maybe, I don't know. You tell me. So I ended up getting what I was after here was the cubic inches per second. So on a 4-cell. So cubic inches per second. So the Racer Star is going to put out 137,160.8. The 0.8 is super important. I'm just kidding, it's not. Cubic inches per second. And the Emax is going to be 154,042.2 cubic inches per second. So I haven't really done much more in comparing those two numbers, but the Emax is going to be more, but I'm not sure if it's necessarily going to be more, as much more as it would seem for the amount of thrust for these two given setups. Anyway, just yeah, whatever. Take that as you want it. And then I was just doing some different things with like wing shapes and stuff. So I calculated this. What did I do? Oh, I did 50. Yeah, okay. So I figured that with the 8-foot wingspan, keeping everything scale, and then having an 8-foot wingspan, so kind of going off of that, the chord, which is from the leading edge, the front edge, to the trailing edge, is going to be about 42 inches, and then I did that times 15% to get the height, or to get the thickness of the wing, because I heard something about how it should be somewhere around something like that. I don't really remember at the moment. Anyway, those are some of the things that I've been doing, because like I said, I'm just kind of in the research and design phase right here. There's some more stuff. Oh yeah, this right here, this is what I was thinking about for the dual propellers. That would be pretty cool. And then, but I was thinking they could overlap. That might be neat. And then also for the front of the fuselage, I think what I'm going to do is actually narrow it down, and it's actually not going to be like a big parachute. I'm going to actually close it in and narrow it towards the motors, because I think that will look way cooler and also perform much better. And I'll figure something out with like how to access the battery. Maybe I'll put like a little hatch in there. And these are just some of the other things that I wrote down from like Value Hobby, ESCs, prices, stuff like that. So anyway, that's what's going on. I got this motor, and so expect to see some testing on that. I think that's it. Oh, and shout out to Big Gear. At first I thought it was Big Bear, but it's Big Gear. Thanks for commenting and your kind words and watching my videos. I think that's pretty cool. Hey, also, I just got these big propellers, so check this out. This is a 10-inch propeller. Wait, stay right there, microphone. This is a 10-inch propeller. This is an 18-inch propeller. I'm not doing that very well. Look at that. Size difference. This thing is massive. This is the most massive propeller that I have ever personally used or am about to use. So this is going to be really fun. So stay tuned to see this thing spin around, because wow, that's exciting. Yeah, so hey, this has been kind of a long video, just me rambling, but if you're into that kind of thing and you want to see how this thing turns out and maybe even give me some input as I build it, stick around. Thanks for watching, and leave a comment. Let me know what you think of this. Any good crazy ideas, paint scheme ideas, I'm all ears. So I'll see you guys next time.